Hello guys, welcome back to Sabima tutorial. Today we want to look at examples on solutions involving sine rule. We'll be solving triangles using sine rule. In my previous video, I was able to derive the formula sine rule, the sine rule formula. A over sine A equal to B over sine B equal to C over sine C. Alright, so we'll be applying this rule to solve problems on triangle. So check up on the video and feed yourself with that information. Okay, so we take two at a time. Either we take A and B or B and C, or we can take A and C at a go. We don't solve with the theory of them depending on the question given to you and what you are looking for. Alright. So before we solve this problem, it is good we know the conditions for which we use sine rule to solve a triangle. Now, first of all, that triangle must not be a right-angled triangle. When you have a right-angled triangle, we use Pythagoras theorem or trigonometric identity to simplify it. So before you solve sine rule, it must be a complete triangle. Now, when you have a complete triangle, we either use sine rule or cosine rule. We'll be looking at cosine rule in my next video. So but today we are solving the problem on sine rule. So how do we know whether we are using sine rule or cosine rule? For sine rule, the first condition is that two sides are given and one angle is given to you. That angle given to you is facing any of the given sides, just like I have here. This side is facing the angle given here. So whenever you have a problem that looks like this, you use sine rule. An example, I have here as 3 and here as 4. And I have my theta 30. You see, this angle given is facing one of the given sides. Another condition for which we use sine rule to simplify a triangle is when you are given two angles and one side. If I have a triangle, I have my angle here theta and I have my angle here alpha, then one side is given, but that side given is facing any of the angles. It is either here or here. Okay, all right. So but sometimes we are also given here, you discover that this guy is not facing any of the given angles, but then we can derive this angle lambda. We can get it since we have this and we have this. So let's assume here is 40 and here is 79. Add this and add this, remove it from 180, you get the angle at this point. So these are the two conditions that we use to solve sine rule. In my next video, we'll be considering cosine rule, and then I'll teach you the conditions for which we solve cosine rule. Alright, so let's solve this example. The first thing we do is to draw the triangle to represent the information given to us. And before you draw the triangle, observe the angles given to you. I have 82 and 39. This shows me the nature of the triangle I'll be drawing, whether obtuse or acute. Considering the two angles I have, the triangle will be acute because none of the angles there are up to 90 degrees. All right, so my triangle will be like this. Let me call there A, B, and C. I have an angle 39 at B, so here will be 39. I have 82 at C. This is 82 degrees, and then I have A. Small letter A is the side facing the given capital letter. The capital letter is the angle. And then small letter C is here. Here will be small letter B. Okay, so I am looking for this guy, C. Recall, we use the formula A over sine A equal to B over sine B equal to C over sine C. We are using two at a time depending on what we are looking for and the information we have on the triangle. I have my A as 6.73 cm. All right, now let's consider and see which one we are using. The first you take note of is the side or the angle you are looking for. I am looking for C and the angle is given, so I'll be using C. Then look at B. I have an angle here. I could have used B, but the side facing the angle is not given, so B is ruled out. The next is A. I can get my angle here. If I add this and this, I will remove it from 180. I'll get the angle at this position. So I will have my angle A. So A is 180 minus 39 plus 82. If I add the both of them, I'll have 180 minus 121. Subtract here, we have 59. So the angle at A is 59. So I can comfortably use A to solve. Alright, so when you want to resolve the triangle, check out for the side and the angle that is complete. I have angle, I have side. We make use of it. So I'll be using A and C. Let's extract the information here into the formula. So I'll have A over sine A equal to C over sine C. Recall we are looking for C. Alright, so my A, small letter A is 6.73 over the capital letter sine 59 equal to, I don't know my C, therefore sine C is the angle at C, which is 82. Alright, then we simplify. We cross multiply here. C multiply here will give me C sine 59. This number multiply here will give me 6.73 sine 82. Sine 82. Make C the subject formula. That means we divide both sides by sine 59. Sine 59. So that here cancels. We have C to be equal to 6.73 sine 82 over sine 59. Then you point your calculator, the value of sine 82 and the value of sine 59. So I'll have 6.73 times sine 82. 0.9902688068. Please don't approximate at this point. Write down every number and then you approximate at your final answer. Then sine 59 is giving us 0.8571673. Okay, then we multiply. That will give me 6.664504098 over 0.8571673. Then I'll have my C as 7.77. Then we approximate. Let us approximate to 2 decimal places, since I have the given side already as 2 decimal places. And most times when you are not told to approximate to any decimal place or any value, approximate and leave your answer in 2 decimal places. Then I'll have 7.78 because 5 is up to 1. Alright, so this becomes my answer. We've been able to get the side C. We'll look at another example to solidify on this knowledge. Alright, let's solve the second question. To solve this, the first thing I'll do is to sketch my diagram. And before you sketch your diagram at all times, consider the given angles. I have one angle given to me which is bigger than 90 degrees. So this is giving me an idea that my diagram will be an obtuse angle triangle. So if I should draw my diagram, one of the angles must be more than 90 degrees. Alright, so look at this, the side is almost flapping down, even here as 116 because it's bigger than 90 degrees. So I will complete my diagram. So it will look like this. Here is C, okay, A and B. Alright, let's feed up every other place. A opposite to the angle A, I'll have 12.5. C opposite to C, I'll have 17.7, and that is all we have. Okay, so we are asked to find the remaining part of this triangle. That means we are looking for all the angles. We are looking for here and we are looking for here. We are also looking for this side. So we have 3 businesses here. Find this angle, and find this side. Then let's look out for the first parameter we'll be able to discover. Alright, I have here to be complete the angle present and the side facing the angle given. So obviously I'll be using C. And then my A I have the side facing the angle given. For this side, no information at all, so I'll be using A. So the relation I'll be using is sine A over sine A equal to C over sine C. Alright, so we are looking for the angle at A since the side facing A is given. So most times when you are looking for angle, use the inverted form of this formula, that is sine A over A equal to sine C over C when you are looking for angle. Then let us substitute. For A, I will have sine theta, I will still use A. Sine A over the side facing it is 12.5 equal to sine 116 over the side facing it 17.7. Then we cross multiply and divide both sides by the coefficient of sine A. If that happens, then I will have sine A to be equal to 12.5 sine 116 over 17.7. 17.7 multiplied here, and then this multiplied here. Then we are dividing also by the coefficient of this guy. Now we have sine A to be equal to sine 116. This will give us 0.89 over 17.7. Then multiply the numerator. I'll have 11.234925558 over 17.7. We divide. I'll have sine A to be equal to 0.6347415558. Now because A is an angle and we are looking for the angle A, take the sine inverse of this value, you get the side A. Sine inverse of this guy. Alright, so just press shift sine. You press this value, you get A to be equal to 39.400481895. So we can approximate it as 39. Let's approximate the nearest whole number. But don't forget to inform us what decision you have taken. So we approximate to nearest whole number. You must write it down. Okay, so we have the angle here as 39. Okay, so from the triangle, the next thing I can easily find is my alpha, since I have two angles present. To get the alpha, we'll sum 39 degrees and 16 degrees. 39 degrees and 16 degrees to get, if we sum it, subtract it from 180, we get the angle here. So the angle at B will give us 180 minus the sum of 116 plus 39 degrees. Now we add this to 116 plus 39 will give us 155. We subtract, we have the angle at B as 25 degrees. All right, so the next we do is find the side X we have been able to discover here and here remaining days. Now to solve this side is facing the angle at B, so we'll be using B over sine B. Then we choose between A and C, whichever one to use, because A is complete now. I have the angle as 39 and then I have the angle here as 116, so we can choose either of this or this. Let me use A. Therefore I'll have A over sine A. Okay, now the side B, I don't know, I've labeled this X, but let me still use B over sine. The angle at B is 25. We have discovered it as 25 degrees, equal to A. The side facing A is 12. 12.5 over the angle at A is 39 degrees. I will have sine 39 degrees. All right, then we cross multiply in here, we multiply here, we multiply here, then we now divide by the coefficient of B. So I will have B to be equal to 12.5 sine 25 over sine 39. Then we'll have B to be equal to 12.5 times sine 25. Will give me 0.42261861 all over sine 39. This is giving me 0.62932091. Then multiply the numerator and divide by the denominator. 12.5 by B is equal to 8.394338302. Therefore, approximating to one decimal place, the one I have already, they are in one decimal place. So I will round off this one also to one decimal place. But make sure that whatever decision you have taken, you must inform us. This is approximated to one decimal place. Okay, so this becomes my answer. We've been able to resolve a triangle. Whenever you are given a problem and you are asked to solve the triangle completely, though you are required to get all the angles and all the sides of that triangle. Thank you so much for coming on board. Please, if you have not subscribed, click the subscription button, like my video and share my videos to your friends. Thanks a lot.